So let's begin. So let me just share my screen, uh, and we can start with some review of what we have
Yeah.
already covered yesterday.
You mind waiting a bit, Hariharan sir? What do you mean B1 plan, a B2 plan, and a B3 plan? Whatever are you talking about?
No, that's not relevant for you. Okay. So
Okay,
let's
would you
start.
mind if I write this May
No,
11?
Si-
Yeah,
Siddharth, Siddharth, if you want to talk, please raise your hand, and we will discuss. Okay. Is that okay with you, Siddharth?
it is.
Thank you.
I haven't forgotten Narayana Pandita.
Siddharth, you need to raise your hand to speak. Okay. So let's just look at what we did yesterday. Yesterday we were talking about Euler. Okay. And we said that he lived from 1707 to 1783, and lost one eye in around 1730s, totally blind by 1771. Then he did some amazing work, especially during the period of 1728 to 1750, if I have to say, just to mark out some time period when he contributed extremely important areas. Okay, so we saw that some of his results have been uh, extremely noteworthy. One of them is 1 upon 0 factorial plus 1 upon 1 factorial plus 1 upon 2 factorial. Like this, if we go up to infinity, the sum is not infinity. The sum is finite.
How
Sum
did he
is,
become blind in one eye?
sum is, he suffered some disease. So it was some kind of a disease. I don't remember right now,
Yeah, but
but
how did he get that whole expansion was E?
how did he get that the whole expansion was E? So yesterday we discussed this point that uh, that if you take more and more terms, the sum doesn't change. So the
Much.
sum doesn't change much. So it converges to a constant, and that constant he called it as E. So
And
I
how
can,
did he find the value I meant?
sorry.
How did you find the value of E?
So value, he just said that it's a constant and it's an irrational number. It's a transcendental
He
irrational
didn't
number.
say it's a 2.71 blah.
No, no, he just mentioned that in his paper, but he also understood that it's not a rational number. It's an
Sir,
irrational number.
the
Yes.
disease that he had got, it's written at intracerebral hemorrhage.
Whatever that means. I have no idea what is that. I think it affected his brain in some ways, or some connection between the brain and the eyesight. So that was what happened.
Yeah, the
In
brain
those
tumor.
days we don't know anything about medical research, so that could be the problem why it wasn't solved. So today, if he would have got that disease, probably he would not have turned blind. So we can denote this as in a nice notation form. So this is what is interesting about mathematics. You can take some equation and write it in a very concise format. So mathematics has its own language. And what you observe in this case, if you see that the terms as you go later, the terms tend to zero. For n becoming larger, the terms tend to zero, but the sum is finite. Okay. We also
This
saw
is
another.
because the thing at the start, the starting terms are big. That's why it has a finite sum. Then it digresses down.
Yeah. So the sum is converges, sum doesn't diverge. So when we say sum converges means sum is finite. Sum diverges means we don't get a finite sum. So
Sir, I have a doubt.
yes.
Sir, how is the sum of fractions an infinite number? I mean, not an infinite number, irrational number.
Sum of fractions is a irrational number, and that is where this is very counterintuitive, isn't it? That you take all rational numbers,
Sir,
but you
a
get an
rational
irrational
number plus
number.
a rational number is always equal to a rational number, am I right?
Correct. Sum of
Then
two
why
rational
is it
numbers.
here it is wrong? Is saying that E is
Because
irrational.
remember, when we talk about sums, we are not dealing with infinite series. We are dealing with finite series.
I understand now, sir.
So here it is infinite series. That is where things start getting counterintuitive, or things start getting less obvious than what you have already learned with finite series and stuff like that. Similarly, we also did this result, right? 1 upon 1 plus 1 upon 2 plus 1 upon 3 plus 1 upon 4. Like this, if we go on, this sum is infinite. This sum is infinite. Again, what is interesting over here is that as n tends to infinity, the larger terms tend to 0, but the sum is infinite, right? Here the sum was finite. Okay, so you have to be very careful that just because the later terms become 0 doesn't necessarily mean that the sum will always be finite. The terms later down the road can become 0, but still the sum can be infinite. What you see is there is a very interesting thing that is happening if you take the series that gives you the answer E, and that is the terms get closer to 0 rapidly. So they get closer to 0 very quickly as compared to this series. If you compare this one and if you compare this one, right? This is slow, sorry, this is quick at becoming 0. The larger terms are quick at becoming 0. Here, the larger terms are slow at becoming 0. Okay. So I repeat, just because the later terms become smaller and smaller doesn't necessarily mean that the sum is finite. So you can have cases where the later terms become smaller and smaller, but the sum is infinite. And there can be cases where the later terms become smaller and smaller, but the sum is finite. In other words, the later terms becoming smaller and smaller is not a necessary condition for the sum to be finite or infinite. So you cannot say. So if somebody comes and tells me, see, this is a series, the later terms become smaller and smaller, therefore I think that the sum is finite. So the answer is it's a false statement, because we know a counter example. We know a counter example where the later terms become smaller and smaller, but the sum is finite. Sorry, sum is infinite. Okay. And we also saw a result that we proved. And what we proved was we proved that the zeta of, sorry, not the zeta. We proved that if we take the sum of all the reciprocals, if we take all the sum of reciprocals, it is equal to the product of 1 upon 1 minus 1 upon p, where p is all primes for all p's. Okay, where p is all primes. So you can take a sum on the left hand side and it is equal to the product on the right hand side. Okay, sum on the left hand side. So this is the famous Euler sum product formula. Sum product result. Okay, we proved this in our problem set. If you are not clear, please refer to the solution, because this is one of the most important results in analytic number theory. So this marked the beginning of a field in mathematics called as analytic number theory, where you are dealing with numbers, but you are analyzing what happens under certain situations. And Euler introduced something called as a zeta function, but he defined the zeta function. He defined the zeta function for s being natural numbers, s being natural numbers. And we all know that zeta of 1 is infinite. We know that zeta of 1 is infinite. We did that in our problem set. We know zeta of 2 is pi square by 6, because this is the famous Basel problem. This is the famous Basel problem. And remember, this was voted as number 5 in terms of the most elegant results in mathematics. Zeta of 2 is pi square by 6. Please pardon my drawing. I am not good at drawing at all. So my zeta, I am writing it as z, but we will read it as zeta because that's how mathematicians define it. So I don't want you to get lost when you read something online and see, oh gosh, what is this zeta all about? It's nothing but a notation. Like you, I, everyone has a name. Similarly, the function has a name, and that function's name is zeta function. Nothing more, nothing less. Okay, so don't get intimidated by zeta. It's just a name given. Okay, and we also know that for all zeta which are even numbers, there is a closed form solution like this. We have solutions like this. Okay, but we don't have closed form solutions for odd zetas. We don't have closed form solutions, but we do know the constant for zeta 3, zeta 5, and those have been applied in physics. I don't know the applications because I have no background in physics, but I have read that it has been applied in physics. So this is a very important function. And I assume that today in Sundar's session, you would have done something related to Raymond's hypothesis,
No,
right?
P
And for
versus NP
No,
function,
sir, we're
not
going to do Raymond
Riemann.
hypothesis on Thursday.
We did P versus NP problem.
okay, maybe he's doing one more session. In that
Yeah.
he's going to cover.
The
So,
bars. Okay.
so
But what
the
about
Raymond's
zeta of
hypothesis.
2n and zeta of 2n plus 1?
So zeta 2n, there is a result which I want you to
Can you
look
tell
up
me
on
the
your
result?
own.
Can you tell
No,
me?
I want you to
We need to
go,
find the result.
not find the result, read about it, because finding the result will
Tough.
need lot of
Tough.
groundwork. It's not tough. I mean, it just that you will need more reading of these topics before you can jump into this.
Yeah, but is there a way that zeta of 6, zeta of 4 and zeta of 8 are related to the original solved zeta of 2?
Yeah, so zeta of 2n, there is a result by which you can substitute any value of n and you will get the result.
Zeta of 2n plus 1. That's not solved.
That is not solved. I mean, we don't have a closed form solution. Everybody, everybody meaning people have looked at an infinite series to find out the sum,
Well,
but we
let's check
don't have a.
zeta of 1, zeta of 3 and zeta of 5 blah blah blah, and let's check if there is a pattern. Then we'll prove it later. First pattern, then prove.
So that constant is not something that they have been able to convert it into a very elegant form like Euler did with the Basel problem. Okay, so these are
Of
I think that the
-1.
main, I think that the main stumbling block for 2n plus 1 is that you don't like all odd numbers do not share any common factor, unlike the even numbers. For example, all even numbers have a common factor of 2, but in some odd numbers may be divisible only 3 and 7, and then maybe divisible by only 13 and 17, let's say. So you
Yeah,
can't
that's
really
a good
say
point.
what what exactly.
That's
They
a
don't
good point.
share a common device or a set of devices,
That's a
except for
good
one,
point,
of
Devansh.
course.
That's a good point. That's a good point. That could be the case why we do not have the. It's not easy to find a closed form solution.
Yeah,
I
it's
don't think it will
not
be possible
easy.
if you
But
have this
what shall
algorithm.
we do?
Hmm.
What shall we do? Probably we can like organize a research.
Hmm. Okay.
Research of
So
the epsilon zetas or something like that.
okay. Okay. Let's proceed. So when Euler started with this analysis, he was only interested in s being a positive integer. Okay. So that's
Zeta
how he
negative
started.
is crazy.
So we will not talk about the negative part because we have other things to talk about, and the idea is to give you an overview of what he has already done. Then we know that there is a very famous result, e raised to ix is equal to cos x plus I sin x. So this is a very remarkable equation that he arrived at again in 1748, where he found out a relationship between exponents, complex numbers, and trigonometric function. And for x is equal to pi, we get e raised to I pi equal to minus 1, or e raised to I pi plus 1 equal to 0. This is also called as the famous 5 equation, because 5 of the most beautiful numbers or important numbers in mathematics have come together, and
E, I,
this,
pi, 1 and 0.
yes, so this result was voted as the most elegant result in mathematics in 1988. And we also saw that there is a way by which we can get I raised to I raised to I by substituting x equal to pi by 2. Okay, I'm not going to give you the steps how it comes. You can try on your own if you know something related to complex numbers. So once you have done the basics of complex numbers, you will get I to the power I. Now I to the power I is kind of difficult to uh, visualize or difficult to
I
comprehend,
is
because
bad enough. I power
yeah,
I is bad enough.
yeah, because we are talking about an imaginary number to the power of another imaginary number.
Yeah,
So he
we
also
I
can
this
visualize it.
result was found.
We
Then
can
he
visualize it.
also gave a result related to a plane geometry, right? The relationship between edges, and you did this result somewhere, or you already know? Can someone tell me the result of? Very good, Ishan. Very good. This result, right? Again, this was voted as number 2 in terms of the most elegant result. And uh, then we also saw a result in geometry called as the Euler line. The relationship between the orthocenter, circumcenter, and what was the third one? Orthocenter, circumcenter,
Centroid.
and centroid, where the medians meet, right? So the Euler line. So it's not just that he has contributed to number theory, he has also contributed in the field of geometry.
also the famous theorem. The distance between the circumcenter and the centroid is twice the distance between the orthocenter and the distance between orthocenter and centroid is twice circumcenter and centroid. Yeah,
Correct,
I
correct,
also
correct, correct.
think I get confused.
Very good, very good, very good. So Euler line. Then we saw
Not
some
in center. It's not the in center.
no, there is no in center. Circumcenter, orthocenter, and centroid. Okay. Then we saw some explorations that were done factorizing the polynomials into first degree and second degree. Then we did something related to partitioning of numbers. I will just go over the partitioning of numbers real quick because that's what we were doing. Yes, he also did bridges of the Königsberg problem, right? He did bridges of the Königsberg,
Sir,
which
And he
was the
proved
beginning
it's
of
impossible. He proved it's impossible.
some of
right,
them
and that was
were possible.
and that's how he came to the idea of graph theory, which is a very big area in mathematics today. Okay, so
Sir, on
now
the site I had solved four. There were four. Two of them were not possible, and
mhm,
other one were possible. I think there was a circle, one type of
mm,
that, and one more was there.
Sir, and we also did Euler's conjecture.
yes, and people disproved it, and it became a big uh, uh, hit, so to say. Then we did amicable numbers, very important, because we dedicated an entire problem set one for amicable numbers. So is a number where the sum of the amicable number is a pair of numbers where the sum of the divisors or the proper divisors of m give you n, and sum of the proper divisors of n gives you m. So we were talking about sigma m, but we know that sigma m includes m as well, so we have to remove m. And we know that sigma n will have n in it, so we have to remove that. And if we add these two, we know that sigma m will be m plus n, and sigma n will be m plus n as well. So using these two, we can say that sigma m equal to sigma n equal to m plus n. When m and n satisfy these conditions, we say that m and n are amicable. M and n are amicable. So it is only obvious that m and n will have some common factor. Let's say a is the common factor, and p and q are prime numbers, or r is also a prime number. Okay, a is the GCD between m and n. So what we can say about sigma m is, we can say sigma m is equal to sigma a times sigma p times sigma q. Where is this coming from?
Problem set 1.
Yes, problem set 1, we proved this result.
Question 4.
Similarly, sigma n can be written as
A, P, and Q should be co-prime.
yes, a, p and q should be co-prime. Yes, that is correct, because if a, p and q are not co-prime, then what will happen is we can always bring the terms that are not, so we can always convert them in such a way that they are co-prime. Okay, so sigma n can be written as sigma a times sigma r, and if we equate these two, right, because we know that if we want to find amicable pairs or amicable numbers, then we want sigma m should be equal to sigma n. And that means we will have sigma p times sigma q should be equal to sigma r. Right? And we know that p is prime, so we will get p plus 1. Q is prime, so we will get q plus 1. And r is prime, so we will get r. And you can start thinking about how to go about doing this or thinking around this using the results in problem set 1. Of course, I will share an article where amicable numbers has been discussed.
I simplified this to make like PQ plus P plus Q is equal to R. PQ plus P plus Q is equal to R.
Yeah.
Since p plus 1 into q plus 1 is pq plus p plus
Yes.
q plus 1. So
Yes.
remove 1.
Yes. 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 And
Notice
also
remove the
remember,
number
you can
1.
also find m plus n. We know that sigma m equal to sigma n equal to m plus n. Okay.
Yeah.
So from there we can also equate this to, because we said this equation 1 is equal to equation 2 equal to equal to not this, but we can get a separate equation where we will get apq plus ar, and we can take a common and do the algebra. So it is all mind boggling substitution which got Euler the way by which he can reduce the trial and error that is involved in finding the amicable numbers. Okay, so this amicable numbers can be a course in itself. It can be a 3-4 sessions we can dedicate to amicable numbers. So let's not get into that. I will share an article. The idea is to give you some overview of this topic. Then we did partition of numbers. I hope you could understand the solution that I shared, because I did not want to spend time on that in the class. So we said that d of n is the number of ways of writing n as the sum of distinct whole numbers. And from there, we also saw what is odd partitioning, number of ways of writing n using only odd numbers, not necessarily distinct. And we observed that it looks like d of 5 is O of 5. We tried it for n equal to 8, and we found that d of 8 equal to O of 8. So the question is it always true that d of n
It
equal to
ends
O of
at
n?
8:15. At least, not normally at 8:15. The
Okay.
lateness is still 9.
So, Siddharth, please don't talk in between.
Sorry.
If you have a question,
I
please raise your hand.
accidentally was unmuted.
Okay. And then the question is, can we prove that d of n equal to O of n? And this was the first time something called as generating functions was used. And generating functions is a very, very, very highly researched topic. Ramanujan used generating functions a lot. So this is called as a generating function because this function generates d of n and O of n. So we saw the algebra over here, and we said that if you take these terms, this is nothing but x to the power 5, x to the power 5, x to the power 5, and these are the distinct ways of reaching to number 5, or not the distinct ways, number of ways in which I can reach to 5 using distinct digits. Number of ways in which I can reach to 5 using distinct digits. So the coefficient on x to the power 5 gives me the number of ways in which I can reach to 5 using distinct digits. So p of x can be written in this way, and you can see that there is a d of n over there. Similarly, he used another generating sequence, another generating function q of x. And when you simplify q of x, because I can always write 1 upon 1 minus x as this, because we know that it's a sum of an infinite series. Similarly, I can write the 1 upon 1 minus x cube as this, and I can also write the 1 upon 1 minus x to the power 5 as this, and so on. And when you simplify this, you observe that you can compile the terms in such a way that this gives me x to the power 3 only using odd digits or odd numbers. This gives me x to the power 4 only using odd numbers. This gives me x to the power 5 only using odd numbers. Okay. So in other words, the infinite series, or the function can be written as a series where you have O of n. So the story so far was this. And since we wanted to prove that d of n equal to O of n, it is enough to prove that p of x is equal to q of x. And this is what we did in that Word doc in the PDF that I shared yesterday. Okay. So some of the great quotes on Euler. Euler lacked only one thing to make him a perfect genius. He failed to be incomprehensible.
What
Because
does
the
that
ideas,
mean?
because the ideas of Euler are not that difficult to grasp, people do not treat him like a genius because his ideas. So the point over here is that the way he has explained things, or the ideas that he has got, they are not necessarily complex in terms of the way in which he attacked those problems. So he failed to be incomprehensible. It's a compliment to Euler. Incomprehensible means something that you cannot comprehend, something that you cannot grasp. So he failed to be incomprehensible. That is, he failed to be not being able to grasp by people. His ideas were easy to grasp. So actually, that's a very compliment. Talent is doing easily what others find difficult. Genius is doing easily what others find impossible. Okay. So talented people make it easy, or make things look easy when others find it difficult. And genius find doing things easily what others find impossible. And that was what Euler was, because Euler was doing things that others found impossible. And that is the conclusion for our session
Yeah,
on
yeah.
Euler.
Professor
Okay, so
Euler.
these are some of the references that I used. So you can always go through the references, and I will share a couple of articles that you can use. But most of my talk is inspired from William Dunham, who is a researcher, or who has done extensive work on Euler's life. William Dunham. So most of the talk is taken from these articles and his lectures. And if you see this, the genius of Euler, 2007, 2008. Why do you think 2007, 2008 we see a lot of articles on Euler? Why do you think 2007? What do you think 2007
Maybe at
was?
that time, a person published a lot of articles about him, which were
Yeah,
not
why?
published.
Why do you
Can I
think
tell?
2007?
Some sort of
Can
anniversary.
I tell?
Sorry?
It
Some
was his
sort of
100th anniversary.
yeah, some sort of anniversary. Like death,
300th
birth.
anniversary.
Was it a 100th anniversary? When was Euler born?
His
Sir,
100th
300th
anniversary.
anniversary.
It was his 300th anniversary. So 300 years later, also his life is celebrated, or his mathematics is still considered very important. Okay, that is what we mean by becoming immortal. You don't become immortal physically, you become immortal by your work. You become immortal by the contributions that you have made to society. Okay, so immortal is not about living after death. When we say in physical form, living after death through your work. And that is the greatness of Euler, that even after 300 plus years, his work is still relevant today. His work is still relevant today. Okay. Ishan, you have any questions, comments?
Yeah, I have a doubt.
Yes.
In the means in one of the slides it was written, Euler was totally genius, but the one thing which he lacked was he wasn't incomprehensible. But
Yes.
if he is comprehensible, even if the solution is very hard, then he might still be then he is a more genius
Yeah,
means
exactly.
genius than
Correct. What you are saying is absolutely correct. Actually, that quote is a compliment to Euler. It is not said in a negative sense. It's said in a very positive sense. Okay. The fact that he has been doing something very complicated mathematics, but still he has come up with some simple ideas to communicate it. That is the genius of Euler. That is what that quote is. The quote is said in a very entertaining way. So that's why the meaning doesn't come out the way it is supposed to be. It is not said in a negative sense. Yes,
Something
Pragya?
like sarcastic, but not exactly sarcastic.
Yes, yes, that is correct. That is correct. Okay, so that is what I had to cover with Euler session. Um Let me now, we will start with introduction to game theory. Okay. So we will do, so 2 days I have dedicated to do the theoretical foundations of game theory. Okay. I am pretty sure that everyone knows what's a game. I am pretty sure that what everyone knows what's a game.
Everyone knows that.
So can you tell me some of the characteristics of games? Some of the characteristics that come to your mind? One at a time. Please raise your hand. Don't start talking. I will ask you to unmute and then you can talk. Yes, Tanish?
Games always have a goal.
Games always have goal. Okay. Okay. Goal. Just scribbling on my screen. Yes, Anushka.
So there is a
Anushka, can
specific, yes, there are certain rules you have to follow while playing the game, and there's a method of playing it, and there are players who play it, and
so
you win, and you also win or lose in a game.
okay. So you have players. Can you have one player?
Yeah, yes, you can. Like for Tower of Hanoi or something like that, you can only have one player.
So, but when you say one player, there is something happening with that one player, right? I mean, there is some strategic element, or there is a other party doing something to
No,
that.
only when there's only one player, I think there's a strategic element you have to use to. Um,
Can you give me an example of one player game?
Tower of Hanoi.
What is that game about?
Like it's a game where you have three pegs, and
Mm-hmm.
all three of them have like a specific, like one of them has a specific number of discs with holes in the center. Like you pile all these discs, and each disc is bigger than the other, and you have to find a way to shift all these discs to another peg without placing a bigger disc on a smaller one.
Okay, okay, okay. So that seems to me more like a puzzle. Would it be fair to say that it's less of a game, more of a puzzle? I mean,
Uh,
every puzzle can be treated like a game as well, right?
yes, actually, yes.
So it's more of a puzzle than a game, because when I think of game, or whenever we talk about game, we are talking about at least two players, where every player is trying to outwit the other player, where every player is trying to outwit another player. Okay.
So there have
But
to be at least two players in a game.
yes, yes,
Okay,
yes.
okay.
And that we are talking about competitive games. Competitive games. Okay. There are some times you also play cooperative games. Can you think of a cooperative game? Tell me a real world example, or first let's talk about some game that you know which is a cooperative game, where you cooperate rather than compete.
Sir,
Pragyan, Sudoku. How is Sudoku a
sir,
cooperative
is it
game?
a prisoner's dilemma?
Okay.
Like
Okay.
it can be solved if the two cooperate.
Mm-hmm. Okay. Football, cricket, Vihan. Football, cricket. There is a competition. So within
Yeah,
a team, you
but
are cooperating.
yeah,
I'm talking about a game itself where you do not compete. You just cooperate. What you
uh,
are talking about is within the team there is cooperation, but across the team, between the teams, you understand the word within the team and between the team?
yeah.
Yes. So between the team, it's a competition. Okay, Srinandan, very good. Pandemic. If we want to solve the problem of pandemic, we will have to cooperate with each other. We cannot compete with each other. We have to cooperate. Of course, again, I mean, technically, if you see the other party is the virus. So you are playing a game against the virus. So philosophically speaking, that is also a competition, but we are still talking only about humans here. So humans have to cooperate to beat that problem. Okay.
I feel that the Raymond's hypothesis is a game, a cooperative
Ah,
one.
it has to be so people have to cooperate with each other to solve that problem. Is it? Very interesting. Yes, Siddharth. Siddharth, can you unmute yourself? Do you want to say something?
Okay, so it's like a game has goals, rules, players, and there can be competitive or cooperative. I think cooperative is like team games mostly.
Yes, you cooperate. Okay, you cooperate. You have to. In fact, it will be worse to. I mean, it will be bad if you actually compete in that game. So you can get better outcomes by
Okay,
cooperating.
team games are normally cooperative games, and
So
individual games are competitive.
yeah,
For
just
example, four-player chess in teams. That's
yeah.
definitely a team game.
Yeah. So there are two elements to it, right? Within the team, you are cooperating, and between the teams, you are competing. Okay, Anushka, you want to say something, or was it from the previous one that you
I
forgot
mean,
to give one example?
between the team.
Team A and Team B. So Team A has two players, Team B has two players.
Oh, so between teams, they are basically competing, but within
Yes,
them, you're cooperating.
yes,
Are
yes.
bots and NPCs counted as players?
Yeah, you can treat them like players. You can treat them like players. See, remember, competing means what? What is a competition? In competition, you want to achieve a goal, and the other party is not allowing you to reach to that goal. That is what happens in a competitive game. You have a goal, and the other player doesn't allow you to achieve that goal. That is what happens in a competitive game. Okay. Uh, yes, Vagisan.
Yes, so I feel like another part is like a rule strategy and what is called as like the UI and stuff like that. UI is like what I'm telling is that like let's say the game is chess, and on the chess you have the board, the chessmen, and so they are the all like the UI, and the UI for Monopoly is that the banknotes, the cards
Hmm.
with places and all.
Oh
The,
yeah, actually, I need to tell
and
something.
there is one
Siddharth.
board
Siddharth. Yeah.
and there is one board, and then there are also like extra cards like community chest. So like that's what is
Hmm.
Monopoly. So each game has like a specific set of UI, and so I think that should
Okay.
also be taken in place. And there are also like
Yeah, the
different
background.
strategies in the, but not
Yes.
actually the background. Like what can you use for all those pawns or tokens when in board
Right.
games are the playing
Right.
cards, and so they I I would so like what's the theoretical name in game theory? I would like to know that.
Yeah, yeah, very good, very good. Shriram?
I don't think there can be cooperative games as such
Ah,
because we are always competing against someone or the other.
very good point. Very good point. So I think it was Srinandan also who pointed out that we can treat the virus as a player and treat the pandemic as a competitive game. So what we are talking about
Sir,
is when we talk about playing against the virus and all, we are talking about human beings coming together to solve a problem. So when you come together to solve a problem, you are cooperating. Okay. So as I said, when we are talking about team games, within the team you are cooperating, but between the teams you are competing. So you can look at from that perspective. When from one dimension it's a cooperative game, from another dimension it's a competitive game.
sir, so like this, like there can be like no cooperative games, like because the game you are playing, there's a certain goal you need to achieve, and like
Mhm.
be some difficulties, and we can call them as like our competition. So
Yes, so that is a competition. But let's say you and I have the same goal, and only way by which we can, I mean, we can achieve that goal by cooperating with each other. If we compete, we cannot do that. For example, let me take another example. Plastic waste is a huge problem, right? Plastic waste is a huge problem. Plastic needs to be recycled, plastic doesn't get decomposed, etc., etc., etc. So if human beings cooperate, we will be able to solve the problem.
Most unfortunately, human beings do not.
So that is a different question. That is a different argument. But the point is, there are certain problems
Groups.
where cooperation may yield better outcomes than competition.
But but
So you should,
still there will be both cooperative and a competitive way.
yeah, there will be cooperative and competitive elements, but we are only looking at solving a problem. And when we define,
In
so
the
you will have to
fastest
define,
time.
so you will have to define the things in games before you proceed, so that you are aware what is happening. Okay. Yes. So that's what I am saying, Srinandan. So there are two dimensions to a team game. One is within the team you have to cooperate, and between the teams you are competing. So there is a cooperative element. Thinking about in what dimension are you looking at? Are you talking about within the team, or you are talking about between the teams? Between the teams it's a competition. Within the team it's a cooperation. Like how if you are asked to solve a problem in the group, so it's a cooperative game. You all should cooperate so that you can solve the problem. Solitaire, again, it's a competitive game because you want to solve that problem, and someone else, the computer in your case, is trying to not allow. But I don't think solitaire is a game in the sense of game theory, because the computer is not strategic in solitaire. What do I mean by strategic? Strategic meaning you play you make a certain move. The computer doesn't counter that move because you played something. In other words, it doesn't change the strategy based on what you do. In solitaire, I think the cards come random. I think the cards that you get in solitaire is random. I don't think the way you play influences the computer's algorithm to provide you with certain cards.
Actually,
Chess
there are
is
different
a
levels
game.
where I can select.
Okay, so there you can actually make it strategic, is it? So when I say strategic, what do I mean? So let us understand the meaning of the word strategic. Strategic means the other player will change its actions based on the action you do. So your actions will change the actions of the other player. Your actions will change the actions of the other players.
Yes,
If
so
that is the case, then we say that the player is strategic in nature.
oh
Okay.
yeah, and I have
Okay.
one more thing. I need to say one more thing. So basically, you will have to like think two moves. So you have to play a game. You have to think what would be the most probable counter. You'll have to see the most probable counter and figure out a way to counter it before you can counter. I think I'm using too many counter words here.
Yes. Yes. But you're right. You're right. You will also have to think what your opponent is going to do.
Yeah, basically
Because
like think 2 moves, 3 moves ahead.
yeah, because your opponent changes the moves based on what you play. Okay. Yes, Swasti.
I just wanted to say that solitaire is a one-player game, and you said before that there are no one-player games.
Ah, yes, it is a one-player game, but in some sense, that's where I am not sure whether the computer algorithm is designed in a way that what you do with the cards that you have, the computer changes the cards. If that is the case, then it will become a game. Otherwise, it is not a game because it is
It's
just a
random.
random deck of cards that is
It's
shuffled. It's not done with a purpose of troubling
yeah, I'm
you.
taking like
It
notes.
is
Yeah,
not
I'm
done.
taking.
It is not written with the purpose of troubling you or not or creating a hurdle in achieving your goal. That's not what it is. Okay. Ideally, cooperative games doesn't exist, so you can think of pandemic. If you want to solve, the only way you can solve is if you say that okay, we will all cooperate with each other and we will follow the norms that are required to not allow this pandemic to spread. That is the only way. Yes, it is hard to achieve, so we will talk about the yes. So again, that's the point over here. Again, that's the point over here. How do you call something as a competitive versus cooperative? Here all human beings are treating themselves as a team. So within that team, I'm only looking at what human beings should do over here. So I am looking at only one dimension of the game. I'm only looking at one dimension of the game, and I'm looking at how that dimension of the game will influence the outcome. So that's where you will have to say that okay, it's a cooperative game. Okay. Or let's put it that this way, non-competitive game. Okay. Yes, Tanish.
I wanted to say, like, when you said strategy, um,
Hmm.
so like I think in strategy also there are two different types of games.
Okay.
So like
No,
the
no, no.
first type,
Wait. I'm not saying strategy as a type of the game. Strategy as an element of the game.
yes, but then like
Hmm.
there are two types of games in which strategies act in different ways.
Hmm.
So for games like chess, like there is no
Hmm.
direct strategy because there is no guarantee that one person will win. Because if both players play like the best moves, then the game will always end up to a draw.
Yeah. So draw is
Uh,
also an outcome of the game. So draw is
yes,
also an outcome of the game. So my goal may be to not win, but not lose. My goal can be not to lose, right?
yes,
So it all depends on how you look at these things. So you have to define
yes,
these things before you can proceed. Okay.
yes. But I'm saying
Yes.
like there's no guarantee. If you have to win a game, then there's no
Yeah.
guarantee that you
Yeah.
will win. So there's no
There is no
strategy which
there.
can be used.
Yes. No. So strategy is not that any. So strategy doesn't mean that it should always result in fulfilling the goal. Strategy means because your opponent did something, you are doing something based on what your opponent is doing. That is what is strategy.
Yes,
If your
yes,
opponent does something else, then I will do I won't continue doing the same thing. I will change my
No.
action. That's what it means
Yes.
to be strategic. So strategy just means that based on what the other party is doing, I will change my actions. So if the other party is going to do something, I will I will do X. But if the other
Yes.
player is going to do something else, I am not going to do X. I will change my action. That is what we mean by strategy. Okay. Okay,
Yes.
let's not
And
digress. Let's not digress from the topic on hand. Please don't spam the
okay.
chats with things that are not relevant to the topic. Okay. Yes, Tanish, you were saying something.
Yeah, I also wanted to say that, like, in some games, for example, there's a game like, I'm pretty sure you would have heard of it, but then, like, you need to add the numbers 1, 2, or 3 to the number. Like,
Mhm.
we start from 0. Each player has to add 1, 2, or 3, and the first
Yeah.
person to reach 21 wins. So, like,
Yes.
there is a guaranteed strategy for the first player to win in this scenario.
Yeah. So that, hold on to that thought. We will come to that. So there is a
Okay.
guaranteed strategy that will give you a win. So there is something called, there is a name for that kind of a strategy. We will come to that. And we are not always dealing with those kind of games. So those are some of the easier games where you have a sure shot strategy. Not every time you will have
Yeah.
sure shot strategy.
Sir,
For
because like
example,
that only works in two when there are two players playing. Like if
no,
the
not necessarily. You can play stone paper scissors between two players. Is there a sure shot strategy in stone paper scissors?
no sir, I'm talking about Tanish's example.
Right. No, no. What I'm saying is, okay, in Tanish's example, because that is a two-player game. Okay, fair enough. Because if you add more players, then
Then it won't work.
it won't work. Maybe there is
There'll be another strategy.
variation, another variation, or it could be another strategy that can work. But we will not get into that. But there are some games where you cannot have a sure shot strategy. The easiest and the best example where there is no sure shot strategy is stone, paper, scissors. I hope everyone knows this game, stone, papers, and scissors, right? Have you clearly found out a way to win the game? There is no clear cut strategy. Chess is again a very good example. You do not have a clear cut strategy because it all depends on what the other person is playing. But I did not use the example of chess because chess looks quite complicated, because there are so many moves that it's just unfathomable to think about how we can come up with a sure shot strategy. But
Sir,
stone, papers,
even
and scissors seems to be a very simple game, yet there is no sure shot strategy.
sir, even
You
if we
can
see the physical games such as football, cricket, or many of them, there is a strategy, so we can call them a strategic game.
Yes, but it is not a sure shot strategy. It will
Yeah.
not always result in victory. Yes, so those are strategies. Strategies is basically your actions. What action are you taking? And your actions, are they changing based on what the other player does? If your actions change based on other player does, then there is a strategic element to the game. Okay, then we say that you are strategically playing. You are manipulating your move based on what the other person is doing. Yes, Srinandan.
So if there's a game in which many, let's say take pandemic for example, all the human beings have teamed up against coronavirus. So
Uh-huh.
in this, if the human beings have all teamed up against some thing or competing against something, does that mean the game is competitive or is it cooperative?
Right, so you will have to decide how you are defining the game. Are you defining on the dimension of humans versus virus, or you are going to look at, let me just focus on what human beings have to do to beat the virus. So when you say what human beings have to do to beat the virus, now we are looking at how human beings should react to this. So then it becomes a cooperative game. So there are multiple dimensions on which you can look at the game. So in a cricket, if India is playing against England, so there are two teams, it's a competitive game. But what Indian players should do as a team, then it becomes a cooperative game. Okay, so that's what I mean by you have to define on what dimension are you defining or looking at the
Okay.
game.
So if you
So
Wait,
look
Siddharth.
overall as just when you're taking the when you're dividing classifying games as competitive and non-competitive,
Hmm.
you have, every time you classify, you have to mention what dimension you're looking at.
Yes.
So
So
if there are
for computer science people, it could be that humans versus boats is a competitive game because they want to outwit the boat. But for people who are only looking at how humans should solve a problem, like plastic waste, right? Plastic waste. If I want to find out a solution for plastic waste, we all need to cooperate, because unless and until we all decide to reduce the plastic, we will not be able to solve that problem. And that's why those are difficult problems. That's why those are difficult problems, because the complications, because it's a complicated problem. There are so many players. Okay, find out how. Good luck with trying to get the cooperation of two people in the team. Now you are talking about millions and billions of people, and they have to cooperate. So it's a very, very difficult problem to solve.
so another question I have is very similar. If there are
Hmm.
two teams of human, so first of all, if I want to define cooperative games, I mean competitive games, it's a non-competitive games is a game in which a group or there is only one team of humans who compete against another team or group of non-humans.
Hmm.
Then, if there
Hmm.
are two groups of human beings who don't compete against each other, but and their actions don't affect what the other group does, but they have a
Mm.
common objective.
Yes, very, very good. Very good. So hold on to that thought. That's a very good point that you make, that your actions doesn't affect whatever you said. So let's think more on that. So let's into the topic. But you made very good points over there. I will use those points as and when appropriate. Uh, okay, Siddharth, you have something to say?
yeah, I have something to say.
Huh.
Well, what I have to say is, it's like every game will either be competitive from however direction you look at it, competitive, or
Mm-hmm.
competitive in one direction, cooperative in another direction.
Mm-hmm.
But you
Okay.
can't have cooperative on its own. That's kind of
Mm-hmm.
not possible.
Yeah. Very
It's
good. Very
not
good point.
possible to create a game which requires only cooperation, because competitive will always be there since players are required.
Okay.
It's like a
Okay.
game is a puzzle, and without challenges, like you can't do anything.
Mm-hmm. Mm-hmm. Yes. Okay. So let's start. So we will play a game. Okay. Read the instructions very carefully without showing or informing anyone what you are doing. Write down on a paper either the letter alpha or the letter beta. Think of this as your grade in Epsilon India 2021 program. You will be randomly paired with another participant. Neither you nor your pair will ever know with whom you were paired. Okay. So you have to
What does
give.
the last pair mean? Neither you
Wait,
nor
wait,
your pair. What does that
wait,
mean?
wait. So you have to give the grade to yourself. Okay. So this is your grade. Either you can write the letter alpha or you can write the letter beta. Okay. And what will happen is, there is an algorithm. There is an algorithm. That is, there is a matching algorithm. it will randomly pair you with another participant. You have no idea. You have no idea who you will be paired with. So neither you know nor your pair will ever know with whom you were paired. So nobody knows with whom.
Nor your pair will never know. What does that mean?
So let's say Siddharth is paired with Tanish. Okay. Siddharth is paired with Tanish. Okay. Neither Siddharth will know that Siddharth was paired with Tanish, nor Tanish will know that Tanish was paired with Siddharth. Okay.
Okay, so
Neither you
are we
nor your pair.
are we going to organize this right now? Are we going to pair ourselves?
Wait.
Even the TAs will be
Wait.
paired.
Wait. Okay. Yeah. TAs will also play the game. Okay. Sriram, when we say grade, it's a very good point. Thanks for asking that, because some of them may have a doubt. It's a grade, that is, it is your marks, like how you have A plus, A, B plus. This is not the standard, like grade 6, grade 7, not that way. It is your marks in epsilon. It is your performance on epsilon, in epsilon. Okay. Okay. Now let me clarify some of the questions. Yes, Tanish, you have a question? Doubt?
No,
Question?
I don't
Comment?
have a question.
Yeah,
Okay.
but then when shall we start playing the game?
Wait, Siddharth, wait. Wagi-san.
Oh yeah, I had a comment actually. I forgot it, but then I remember now. So my comment was that for games like chess, we can't have a strategy because there are estimated some 10 to the power 110 or something possible.
10 power 120.
10 power 110 to 10 power 125, I think. Somewhere between that.
It's 120. 10 power 120.
Okay, Siddharth and Tanish. Yes, that's a good point, that it may be difficult to come up with strategies, because it's very difficult to think about these possibilities.
The way
And
to
that's
learn
where,
chess is through experience. That's the fun in it.
correct. And that's why it is getting more and more difficult to, or almost impossible to beat the computer. Okay, anyways, let's not digress. Vanya.
Yeah, I wanted to say, like on the previous slide, that you cannot have a game which is cooperative and but is not competitive. Like you are cooperating, but for what? Like you want to defeat someone. You and your partner working to like defeat someone. Otherwise, like, are you cooperating? So there cannot be a game in which you cooperate, but there's no competition.
Because you can always treat some player as I mean, it can
because
be
then there's
an
no use
invisible
of
player.
cooperating. Then there's no use of
Yes,
cooperating.
very good point, very valid point. Nice. Okay.
I have my last comment. So the comment is that, like, let's say like China and rest of the world are linked. So let's say that's the case. And but then here, like when we are saying this, rest of the world is a different is one identity, and China is one identity. So so sometimes a team can be considered a different identity, and so like that's allowed. And now, like when we are getting alpha or beta for the epsilon, then what if like how will we know the pair? So
that is
so what will happen when the pair comes? We don't even know, right? Will we meet or something like that? That's the doubt.
Yes, very good point. So what I am expecting you to ask was something what Raghav asked. Raghav asked a very good question. Which one is better? Alpha is better or beta is better? I have not defined anywhere alpha and beta. So the question that you should have ideally asked is, alpha is better or beta is better? Okay. Okay, so that's very important. You should know the game. What is the objective of the game? So very good. Srinandan has asked. Vagisan made very good points. He said that if we don't know what we are getting paired against, what do we want to do with the game? Or what will we get? Okay, I can give alpha, I can give beta. What are you going to do after pairing? Okay. Yes, the rules. Yes, the rules. Right now, I only told you the game, what you are supposed to do. You don't know the rules. Yes, Parth, alpha and beta, those are the only two grades. Okay, you can only write you can only take, you have only two actions. You can only take two actions. Either you can say alpha or you can say beta. Okay, very good. Uh, let's talk about some of the rules. Now, these are the rules. Now, very, very carefully, please read. If you put alpha and your pair puts beta, you don't know who is your pair. You will get A and your pair will get C. Okay, A is better than B, B is better than C. Okay, that remains the same. A is better than B, B is better than C. A plus is better than A minus. Okay. If both you and your pair put alpha, both will get B minus. If you put beta and your pair puts alpha, then you will get grade C and your pair will get grade A.
Sir, what do you mean by your pair?
Pair. In the first part, in the previous slide, we said that you will be randomly paired. You know, you understand the word
No,
pair?
sir. Yes, sir, I got that, sir. But like if you put B and your pair, sir, I thought there were here the pair meant two people, but now I understood that means only one person.
No. So yeah. Your pair means whoever you are paired with.
Yeah,
So
I
let's
got
say Siddharth puts alpha, Tanish puts beta, and random algorithm picks Siddharth and Tanish as a pair. Then Siddharth will get A and Tanish will get C. Okay. Is that clear? Suppose let's say uh, uh, um, Swasti puts beta, and Vanya puts alpha. And Swasti and Vanya are paired. So Swasti will get grade C and Vanya will get grade A. So think carefully what is the alphabet that you should write. Okay, Tanish, think about it.
So that I
Think
should
about it.
write
No. Don't tell me what should and all. You just play what you think is right. Don't reveal what should be done. There is nothing like should. Or if there is should, why you think about why you are saying so strongly we should. You are using the word should. So be very careful.
I wrote down my answer, but I'm not revealing it. We'll reveal it only after everyone is paired.
Okay. Let's see. Okay, let's see.
So how
Even
will
the
play this
TAs
game
should be
now?
paired.
How we will play the game. So remember that what is happening. So let us talk about what are your possible choices. Can you tell me what are your
You could do
possible
alpha
choices?
or beta. Alpha or beta.
So you have
Alpha,
only
beta.
so each person has two choices, alpha or beta. And what are the possible outcomes?
Strategy.
Your possible outcomes are grades. Okay. So what we will do is we will first take the game and put it in a concise form. It's a very important skill set. It is very important skill to take all the information and put it in a very concise form, easy to understand. So your choices are the strategies. So now whenever you think about what you should play, whether you should put alpha or beta, what you are thinking is what your pair is going to do. And based on what your pair is going to do, you are changing your strategy. Okay.
So basically, what you care is yourself. Basically.
So I got the answer.
Hold on to that. Yes, Ishan, you have a question or a comment?
Yes. Is it really the criteria for deciding the grade?
No,
Or
no,
is
no,
it
no. So
just
there
a
is
thing?
so this is just a hypothetical game. So there is no grading for epsilon that
Okay,
is
okay.
taking place. This is not your grade. Okay. This is just a hypothetical game. This is not a real grade. This is just a game that we are playing. So don't worry
Got
about
Sir,
it.
I
confused.
sent you the answer and why I'm thinking this is the answer.
Whom do we
Okay, then
When I sent you.
in mind.
When I sent you in the chat.
Okay, but
Okay.
then Hari sir will purposely pick so that we each get the baddest mark.
Okay.
Cheating.
No.
Thing in the
Siddharth, I clearly said at the beginning that it will be a random algorithm
And
that will
did
pair.
you literally make an algorithm that chooses it randomly?
Yes.
You made it,
Yes.
or
Yes.
are you going to use your head?
No. It will be. Don't worry about that. How it will happen and all. Okay.
We're not going to play the game. Later, perhaps we can make some sort of random generator for the purpose.
Okay. Let's not get into
Sir,
how the
sir, is this
randomization will
game-
happen.
Is the game real actually or is it made up?
It's
There
just
is
a made up.
actually a game like this called the Prisoner's Dilemma.
It's just a made up game. Now, can we
Actually,
start
it's
with it?
not the same
Siddharth,
because
yes.
you know the people and then you decide based on what you think the person will do, and you probably know the person because you committed the crime along with that person. So you
Yeah,
will
but
have
they don't have any loyalty to each other.
but even if they don't, the one person will know the other person, and it's much better than knowing, hoping for the other person to do something.
Very good. So think about this here. You are
Sir,
saying
I'm
that we
not
don't
going
know
to tell
others.
how that problem works, but that problem is the exact same as this problem.
Make
This one
your
just
own
we have to
decision.
grade.
Don't.
That one we have to confess or
Was that Vanya who was talking?
No, sir.
Who was it? Sasha.
Well, if everyone
No,
puts
sir, it was
beta, we'll
Siddharth, please. Who was that talking? Sorry. Who asked the questions right now about the prisoner's dilemma thing?
I think Siddharth was only talking.
No. Before Siddharth.
I think it was Hariharan.
I
Sir, I
think
was
Parth
talking.
or Hariharan.
No. Sai Arun
No, I wasn't talking.
I was talking about the prisoner's dilemma. I told him.
No, but someone else was asking about the prisoner's dilemma. Huh?
I think it was me.
Who is
Or maybe
me?
not. Srinandan.
Srinandan. Okay. So what you're talking about is a very valid point. You don't know the player, or you don't know with whom you are playing because it's getting paired randomly. But you can think of playing with yourself if you don't know the player, because everyone is going to think like, I mean, others are also going to think like you are thinking. So you can think that way. Okay. Let's please lower your hand once you have completed your question so that we know that your comment or question is over. Yes, Shriram.
The first letter in the table means in the comma represents us, right?
Yes, very good point. So this is for the row and this is for the your pair. So if you select alpha and your pair also selects alpha, both of you will get B minus. If you select alpha but your pair selects beta, you get A and your pair gets C. If you select beta and other pair selects alpha, you get a C, but the other person gets a A. And if you both select beta, then you will both get B plus. Okay.
Can we send all our choices privately to you in
No.
No,
So
Hari
the
so
sir
so
will pick randomly. Now, shall the game start now?
no, wait. So let
Ah,
me ask.
Parth, why did you reveal the answer?
Let me ask you this thing. Okay, let me just. Can we have who is the host of this meeting? Who is the host of this meeting? Okay. Neha, can you make me the host?
Oh yes, sir.
I want to create a poll here.
Yeah, okay.
Tell what your choices are.
Yes. Oh, you created the
Or
iPad,
is
not
it
the
like, do
iPad.
you take
Create the
notes?
other one.
Yeah, okay.
Create the other one as the host. Hari Ramasubramanian as the host. Oh, now I will have to make this poll.
Yeah.
Not. Oh, it doesn't give me that option. Oh no, I will have to go to the
You
iPad
can
and do
go
it, right?
into Zoom and then you
Priyank can get
No.
the
I
host
I got
privileges.
that. I will have to go to the iPad and do that.
and then you can make Hariharan Subramaniam the host.
Yeah. Yeah. That I did now. No, I was trying to do from my computer, whereas I should be doing. Okay, let me see if I can do a poll. It doesn't give
If
me
you
the
launch
option.
a poll, then you have to pick randomly. Pick randomly, okay?
Okay. Let us do this way. How many of you chose alpha in this game? You have to be very uh, true to yourself. Be honest.
Yeah,
How many
yeah,
of you
but we
chose
can't.
alpha?
We have
How
to
many of you
tell.
chose
What
alpha?
should we
Just
do, sir?
so
What should we
so
do, sir?
have to raise the
wait
hand.
wait. Yeah, let me first lower everyone's hand. Now everyone's hand is raised. Lowered down. Just raise your hand if you chose alpha. Just raise your hand if you chose alpha. Raise your hand if you chose alpha.
Hope it doesn't pair me with any one of those. Ayayyo.
Siddharth, if you chose alpha.
Yeah, I did choose alpha and now I'm in for a trouble.
Okay. Can you lower your hands? I can see how many.
I think
One,
there is a
two,
huge
three,
chance of me
4,
getting B
5,
minus.
6, 7, 8, 9, 10. Almost 10,
Anyway,
11
B
people.
minus is not the bad C.
15 versus 12. Okay. Let me ask the question. The other 15 is what, Sai Arun? Is it the alpha 15 or beta is 15?
Alpha is 15, I think. I
Okay,
saw 15 members having their hands raised, 15 members having their hands raised again. But there are a few TAs.
Wait,
Okay. That's fine. So please
I
lower
don't
your
think
hands.
it's 15 alphas and 12 betas.
It is 15
Yeah.
alphas and 12 betas, I counted.
Okay,
Let's see.
Siddharth, let's not get into that. Can
Now
you lower your hands?
can you
Can
use
you
a
lower your
random
hands?
picking machine?
Siddharth, can you please stop talking? Okay, lower your hands. Now, let me ask the same question to people who wrote beta. If you wrote beta, raise your hands. If you wrote beta, raise your hands. If you wrote beta, raise your hands. Okay, now, Sai Arun, can you count?
I believe it is 7 or 8. No,
It's
one
8.
person
One
just
of them
changed their
just
opinion.
lowered their hand.
Parth just changed his opinion. Ah, no, he came back. Sorry.
Wait. This is not allowed. You were supposed to be truthful. You cannot change your answer based on
Chose
what
alpha and beta.
because you had to write down before the this was revealed. Okay, so this is not done. So some of them have changed their answers. Is it, Sai?
Yeah.
Sir, one person, I don't know who that was, but
Okay.
no one has changed it now. Now everyone
Apart
has
from Parth.
Okay.
Parth
So
changed his
around
answer back.
so
Back
so
to
around
beta.
Around 12 people said that alpha, and 8
15
people said
said alpha. 15 alpha
15
and
people.
7 beta.
So almost 2:1 ratio. Almost 2:1 ratio.
Yes.
Let
Yeah.
me give you a good news. You all are in good company, because the same experiment was done in Yale University, and the ratio of people who chose alpha to beta was 2:1.
What?
I know
It
why,
was
sir.
2:1. Okay. Anyways, let's
For the
now
same
Now let's
ratio.
pair. We need to pair.
wait.
Then what is the final, which is better one?
What's our
Final,
grades?
what is better one? So which is
I
the
don't.
better one?
I don't think there
Wait,
isn't
Siddharth.
any
Sir, can I
better.
explain the
Siddharth.
answer?
Siddharth, wait. Okay,
Yep.
Sai, let's come to that. First of all, Ishan asked a very good question. Which is a better one? So now better one depends upon, first of all, what should your strategy be depends upon what you care about. Maybe you only care about your outcome. Okay, maybe you care for your pair's outcome, or so it is you who has to decide the payoffs to the outcome based on your preferences. So it is not that it is not just that the grades, which grade is better. You also have to think, what is it that you want, whether you only care about your outcome, whether you care about your pair's outcome, and everything is fine. It's not that there is a correct way of thinking here. It all depends upon what you care about. You may care about your pair's outcome, you may want to care about your pair's outcome. Okay, let me ask a couple of you who said alpha, what was the reason? But I want someone who has not spoken yet. So raise your hands and I will give the opportunity to someone who has not spoken yet. Who wrote alpha? Who wrote alpha? Who wrote alpha? I
I
will
wrote
give.
alpha.
Okay, Swasti, you wrote alpha? Swasti?
Hello?
Yes.
Hello?
Yes.
I wrote alpha.
So can you tell us why did you write alpha? Your thought process?
Yeah. So, can you just go to the table slide?
Uh-huh. Hmm.
Yes. So, alpha and alpha, if I choose alpha and the opponent also chooses alpha, then I get a B minus.
Mm-hmm.
If I choose alpha and um, um, my pair chooses beta, then I get A.
Hmm.
I get an A. So,
So in
and
some
for
sense you
beta, it
thought
will be,
that let me select alpha. If my pair chooses beta, I am very happy. And if my pair chooses alpha, that so be it. But I don't want to select beta, because if my pair is selecting alpha, then I am in trouble. Is that what you were thinking?
yes, yes, because C
Okay,
is
very
worse
good.
than B
Okay,
minus, and B
very good,
plus is
very good,
worse
very
than
good.
A.
Very nice. Okay, fair enough. Aditya?
Yes, sir. So
Yes.
first, I saw that alpha gets you to gooder marks like A and B minus than
Mm-hmm.
beta.
Hmm.
And I saw in the chat and found out that most of the people will vote alpha. So if I had voted beta, then that's more likely that I would pair up with alpha and get C. So I didn't want to take the risk, so I just uh, made my decision as alpha.
So the point is, even if you were not told what their preference was, you would have still selected alpha?
Yes, sir. because
Okay.
it's much
Yeah. Fair enough.
better grade.
Okay, very good. Vanya?
I chose alpha because first of all, after looking at the outcomes, the reason I stayed to alpha because the conditions were that if you get an A, in the best case you get an A grade. Only if you and your partner get A, then only you get B. Like that will be the worst case. So I considered for the best case, and then I went for it.
Okay. So you did not care about the fact that if your pair is choosing beta, that person is going to get C then.
No.
Okay. Fair enough. We're just trying to understand how.
Selfish.
Smayan, you haven't spoken.
Okay, so
Smayan?
I chose alpha because when you have alpha, the most risk you have is getting a B, and if you choose beta, you always there's a risk of somebody else choosing alpha and you're paired with that person, and then you get a C, and then you're in big trouble because in a way alpha counters beta, but alpha does not have any counters.
Very nice. Okay. So basically you are worried about what you will get in a nutshell.
And the fact that with alpha you can, if you get mashed up with the beta, obviously you get an A. Even if you get mashed up with another alpha, you get a B minus, which is not a C, which is what matters, because there will be some betas who got paired with an alpha and got a C.
Yeah.
Whereas you never get the lowest score, but beta has high risk, but alpha has no risk, like very
So
low.
you are not worried about the fact that people who chose beta will get C. That is not your lookout.
That's not my concern.
Okay, very good. Appreciate that. Raghav.
Yes, sir. Sir, so I first thought first I chose alpha, and there are two conditions. Like if the whole set of people, if you know them, then you can decide whether you want to choose alpha or beta. But if you do not know them, then you would choose alpha, because because you don't know whether the people want how are the people, they want themselves to get a higher grade or they want others to get a higher grade.
Very good. Hold on to that thought. So tomorrow we will pick on this thought that you don't know the people what they are going to do. Okay, very good point. So you thought that I don't want to get a C. Very good. Okay, let us ask people who said beta. Okay, let us ask people who said beta, because I think alpha, it is very clear now from whatever answers I have heard. Most of you thought about your grade, but I want to listen to people who wrote beta. They look like very nice people to me because they wrote beta. They had some different thought process. Yes, Shriram.
I did not use any thought process. I thought B minus was worse than C, so there was no risk about choosing.
No. So B minus is better than, I said, right? A is better than B, B is better than C.
Yeah.
So B minus is better than C. B minus is worse than B plus. So it's A, B plus, B minus, C. That is the order, taking order. Sorry. So would that change your answer then?
Yeah.
If you know that B minus is worse than, better than C, then you would
actually
select.
thought that, but I thought that it was minus, so I put it as worse than C.
Okay. No. So you would change your answer then to alpha?
Yeah.
Okay.
I do did the same. I do thought that
So
minus
I
B will
chose.
be greater than
Wait.
C, because it's like, I thought it's like integers. 1, 3, 2, minus 1,
No.
minus
My mistake. A, B plus, B minus. So you would, Ishan, you will change your answer then?
Yes, I would choose alpha.
Okay. Sorry. Parth.
I chose beta because now if you have an alpha and alpha, then like there's no beta in it. So now if we take beta and alpha, you will be getting a C. So if you list down all the different grades you can get, there is A, B plus and C. And in alpha there is A, B minus and C. So B plus is better than B minus. So hence beta.
So you were hoping that your other pair will also write beta, right?
Yes, sir.
Because if your other pair writes alpha, then you are in trouble.
Yes, sir.
Okay, okay. Someone who has not spoken today. I saw someone who had raised the hand. Utkarsh, did you write beta? Utkarsh, did you write beta?
Yes.
Can you tell us why did you write beta?
Yeah, it was a random choice, but like alpha, and I thought like if my partner was beta, then it could be like.
So you were hoping for your pair to also do what you are doing. So you were hoping, because if your pair chooses alpha, then you are in trouble because you will get C, right? But you okay, you thought, or you were hoping that your pair will do that. Okay. Did anyone who write beta, it came to your mind that, oh God, if I write alpha and the other person writes beta, the other person will get a C, and I can't accept that fact that the other person is getting C because of me. Did
So
anyone
I
think
don't
like that?
care.
No, because it's their fault
No,
they chose
sir.
it.
Yes, sir. I
Who
don't
said that?
care.
Their problem. They could have
They
chosen
made a mistake by choosing it.
low grade.
Who says
Yes,
that?
sir.
Who said that?
Me,
They made a
Sasha.
mistake. Okay, very good, very good. So you are saying that it's their fault. I don't care.
No,
They should have
I'll say,
chosen alpha.
sure, I care. I will give them sympathy afterwards. But they made a mistake. Now they're going
Okay,
to the
okay.
consequences.
No, fair enough. I'm not judging any of you for whatever choices. I'm just trying to understand what you're thinking. It's a very, very correct. I mean, it's a very, very fair thought that yes, they should have thought about it. They could not think, and now they're in trouble.
Yeah,
Okay.
sir, but there's one more downside. If
Huh?
let's say me and my partner both think in the same and choose alpha, we will both end up with a B minus. So in
Uh-huh.
fact, while beta has a risk that if the other person chooses alpha, the people will probably not go for alpha because they will think that, oh, the other guy chooses alpha, end up with B minus. I'll be better off going with the beta. At least I'll get a B plus if the other guy also chooses beta, and if he thinks the same way as
Ah,
me.
so you're talking about cooperation now. So hopefully people will cooperate. So
It's not
in some
cooperation.
sense,
It's more
it
like
is.
predicting what your opponent will do, what your partner will
Huh.
do in this case.
Huh. But others are saying, so the alpha people are saying that I don't expect others to write beta. So we will pick on these thoughts tomorrow
And
because we have
also, sir,
already.
just one point. Beta also has a better average score. Like if you average, if
Mhm.
you assign values, numerical values to A, B plus, B minus, and C, 4, 3, 2, and 1, I think
Yeah.
that alpha, beta will end up with a better average.
Yeah.
So from
Okay.
that point of
Okay.
view, beta also makes sense.
Right. So this is similar to what Raghav was saying, that if you knew people, or if you could say that people are going to select beta, you could have actually come up to a better place than you have now landed up if both of them are paired with alpha. So the alphas are hoping that they will be paired with betas, and betas are saying that, oh God, we are choosing beta with the hope that others also choose beta and we will get paired, and on average we will be better off together than what we were together. So I think betas are thinking more like pairs, where alphas are thinking more like what will happen to my outcomes and why I have chosen alpha. So let's start from here, because if we continue this, the whole night will just go on with discussing this. So thank you so much for today, and we will continue from here. Okay, these are all
Thank you,
very
sir.
valid points. All the points that you are making are extremely valid and correct. So there is nothing wrong about the points that you are making. So there is no wrong answer, so to say. So think about this before our class tomorrow, and we will continue our
Wow.
discussions
The people
tomorrow.
who choose alpha are the alpha males and the alpha females. Wow.
Okay. Okay. Okay, that has nothing to do with this, so please don't
Yeah.
mix those two things up.
We were
Okay,
thinking it like
okay, Siddharth.
competitive and they were thinking like cooperative.
Okay, Siddharth. Okay, thank you so much, and have a good night. See you tomorrow, and I hope you enjoyed the session today.
Yeah, and
Thank you.
anyways,
Yes,
we
sir.
both
Thank you.
were hoping
Thank you,
for
sir.
we
Thank
both
you,
were
sir.
hoping.
Bye.
Thank
you, sir. Bye, sir.
Thank you,
Anyway,
sir.
Bye, sir. Thank you, sir.
Hi, sir. Thank you,
Sir,
sir.
bye.
Enjoy the
bye.
session.
Bye,
Bye,
sir. Thank you,
sir.
sir.
Basically, you're
Bye,
hoping
sir.
for a
Thank
good
you.
outcome. Basically, you're hoping
Thank
for
you,
a
sir.
good
Bye.
outcome. You're hoping for a good outcome, basically. Both
Yes,
are.
yes, yes,
That's
Siddharth.
the silly thing about this game.
Yes,
It's
Siddharth.
basically hoping for an outcome.
Yes. Utkarsh, you have a question or you want to say something? Utkarsh, are
No,
you
sir,
still there?
nothing.
Okay, okay.
We're just frozen here.
So, Tanish, what is the time at your place?
10:15 at night.
So you don't want to have, you had your dinner?
Yes, before this class, I had my dinner.
Okay.
At 8 o'clock, I think.
Me
Yeah.
too. I had my dinner at 6 o'clock here, and here it's 8 o'clock.
Yes, but math is better than
Nearing
sleep,
9.
so it doesn't matter for me. Math
Good,
can make up for sleep.
good, good, good.
Yeah, math can make us sleep no matter how much we worked in the
Not
day.
make us sleep. Math can't make us sleep. Math can make up for sleep. Math is good. Math is too good to make us sleep.
Okay, Siddharth, bye. Siddharth,
Bye-bye.
bye.
Bye, sir.
Bye.
Bye, sir. Thank you.
Bye, sir. Thank you.
Bye.